Substitution rule for definite now integrals. And we have tons to choose from. Here they are, from 45 till so on and so forth. So let's stick with 45 to 62 first, and then we'll turn the page and see what's next. Any preference? If not, I will choose. Okay, I'll choose 47. You choose the next one. The integral from 1 to 2, from x squared minus 1 to the 7th dx. Perfect. Now remember, this function for a definite integral must be on the interval 1, 2. If it isn't, I can't continue.
Continuous.
Continuous. But this is a polynomial, it's always continuous. It's all safe. Good. Now we can, like before, select our substitution. Let's use y. What do you think the substitution should be? Again, it's okay if you're wrong. If we embark on a wild goose chase, we'll come back and do it again.
X squared minus 1 to the 7th.
Just x squared minus 1. Good. This is the problem. Because I don't want to raise it to the 7th power. It's too much. Good. Now we have to determine dy. We cannot continue without dy. dy for this function.
2x dx.
Excellent. 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 It's this. On this side, I have to have only one variable. On the other side, just the other. Awesome. So, do I have x? Yes. Do I have dx? Yes. I don't have the 2. Okay, fine. X dx, I divide both sides by 2. I get dy over 2. So then for now, this piece, this times this, will be replaced by dy over 2. Awesome. Now, what will this be replaced by?
Y to the 7th.
Y to the 7th. So now, I jump over all this. I continue here. Do not copy the limits of integration. The limits of integration are for variable x. We are going to write an integral in y with dy. They cannot be the same. The limit, that's the difference between indefinite and definite. The limits cannot be the same. This says x goes from 1 to 2. When x is 1, how much is the lower limit for y? And I'll put it here.
0.
Excellent. When x is 2, calculate, and that will be the upper limit for y.
3.
That's it. Now, x dx is dy over 2. Awesome. And we have this, which is y to the 7th. I move 1/2 outside, of course. And now I'm asking myself, let me write it one more time, 0 to 3, from y to the 7th dy. And now I have to ask myself which function I differentiate to get y to the 7th. There is only one function that I differentiate to get y to the 7th.
Y to the 8 over 8.
That's it. I'll multiply 1 over 16. And now I plug in 3. Okay, fine. Minus, And when I plug in 0, there is nothing I have to write. So the answer is 3 to the 8th power divided by 16. I have no idea what 3 to the 8th power, where is my calculator? Here it is. 3 to the 8th. 6561. So this is 6561 divided by 16. Notice two different things here. And then we'll choose many problems. Number one, I can never copy the limits of integration because they are valid only for x. When I move to an integral in y, I have to determine the corresponding limits of integration. That's one thing. Number two, I never need to go back because it's going to be, the answer is going to be a number. Before, with the indefinite integrals, I was forced to go back to the original variable. Whatever I did, it was for our benefit to make it easier, but the answer had to be in the variable the problem was given to us in. So in x, the answer has to be in x. T, then the answer has to be in t, not in y. But here, there is no need to go back. I will never do that. There is no need because it's a number. If I finish it up in y, or if I go back and finish it up in x, the answer will be the same. Doesn't matter. So two things to remember. The limits of integration cannot be the same. And the answer is a number, so we do not go back to the original variable. That's gone forever. We are using the easy one to finish it up. So these are the two differences. And now we'll practice. Please choose anything you want from 45 through 62 for now. So let's continue practicing indefinite, I'm sorry, I keep saying indefinite, definite integrals, substitution rule for definite integrals. If you do not pick 1, 2, 3, I will. Anyone? Okay, I will pick 53. The integral from 0 to b. Okay. B is a number. It's just not given to us. They're hiding it. Okay, fine. Not a big deal. So 0 to b from 2e to negative 2x dx. Good. So let u, what do you think?
Negative 2x.
Of course, this is the problem. E to x is nice, awesome. E to negative 2x is not, because this is a function inside a function, e to the x. Awesome. I need du. Without du, I cannot continue. That's my next step. First, I find a substitution. If it doesn't work, I'll go back and find another substitution. Who knows? But I need to find du. For whatever substitution I want to apply or try, I have to find du.
Negative 2 dx.
Negative 2 dx. I have the 2 and I have dx. It's the product. I can rearrange the product the way I like. So, but I don't have the negative. Fine. 2 dx is negative du. Multiply both sides by -1 or divide both sides by -1. So therefore, this equals negative du. Okay, fine. Not a big deal. What about this? What does this represent? And remember, everything has to be changed to u. If there is some left over, it's not allowed. Everything has to be changed to u.
E to u.
A to u indeed. So now do not copy the limits of integration. When the lower limit for x is 0, what will be the lower limit for u?
0.
That's it. When the upper limit or the upper limit for x is b, what will be the upper limit for u?
Negative 2b.
That's it. So now, 2 dx is negative du, so I'll put a negative outside. And I have e to u du. Perfect. Now, I have negative outside, and I want to determine which function prime is e to u. I need a function here that I differentiate to get e to u.
E to u.
Exactly. Leave the negative outside, patiently waiting. I plug inside negative 2b, so e to negative 2b minus, this is not a polynomial. When I plug in 0, what do I get?
1.
Exactly. If you don't want to have, like I don't have a negative leading coefficient, you can distribute it. So I have negative 1 times negative 1, that's 1. And this minus e to negative 2b. If you don't want the negative exponent, then you just have to write 1 over e to 2b. If you don't want to leave it like this, then you will find the least common denominator, e to 2b. You multiply e to 2b minus 1. There is nothing else that can be done here. This is okay, this is okay, this is okay. Two things again. When we use substitution on a definite integral, we cannot copy the limits of integration. We have to determine the new limits of integration based on the substitution. When in x, I replace x by 0, I get 0. When I replace x by b, I get negative 2b. Secondly, I do not go back to the original variable. Who cares anymore? We don't care anymore because we already have the new limits of integration. We continue with those. Okay? Any questions on this problem? Okay, let's choose another. Anything from 45 to 62. So let's work on one more. Unless you want more. Of course, if you want more, we'll do more. No one wants to choose? Okay, I will choose 59. So we have the integral from negative 1 to 0, from x to the third dx, everything divided by 2 minus x to the fourth to the 7th power. Did I manage to copy from two problems? I am very good at doing that. Negative 1 to 0, that's correct. X cubed, yes, that's correct. And remember, the definite integrals you can check with a calculator if you want to. But you're not going to get the exact. The calculator cannot give you this exact answer. First of all, because you have b, you cannot put it in as b. The calculator will not take that. But even if it was, I don't know, b was 1, as an example, you will not get the exact answer. You will get some approximation that cannot be changed into a fraction. So you still need to know how to work on this step by step. Okay, so let's look at the new integral. And let's choose a substitution. Something that bothers you when you look at this function, what really bothers you, something that sticks in our faces. Something that is I cannot work with.
2 minus x.
Exactly, that's the problem. 2 minus x to the fourth is the problem, but now if I don't get the du, then I'm in trouble. I have to get the du. What will the du equal to?
Negative 4x cubed dx.
Excellent. What I show in my STEM classes, instead of solving for x cubed dx, I multiply by -4 and divide by -4. -1/4 times -4 is 1. I didn't change the problem. Multiplying the numerator by -4 and multiplying the denominator by -4 is the same thing. But now, look what happens. This -4x cubed dx, all this piece is du. With a -1/4 in front, of course. What will I replace this by? Because everything has to be accounted for. When I move from x to u, everything has to be accounted for. I cannot carry any x's with me. They're done and over with. They're not coming over for dinner. They're gone.
U to the 7.
Yes, this must be u to the 7th power. So -1/4. The integral stop because we need to determine the new limits of integration. When the lower limit for x is -1, when this is replaced by -1, the calculation will give us the lower limit for u. -1 to the 4th is 1 because the power is even. 2 minus 1 is 1. Now I need to find the upper limit when x is 0. When x is 0, 2 minus 0 is 2. So the limits of integration for x, -1 to 0, gave us, through the substitution, 1 to 2. We know that the top is du, and we know the denominator is u to the 7th. Notice that x is gone. Everything was accounted for. Everything was transferred into u. But now I have to change this 1 over u to the 7th into what in order to continue solving it? One over u to the 7th has to be changed into what? Not the derivative, algebraically. 1 over u to the 7th is the same with u to which power?
U to the 8th. Oh.
So u to -7 is 1 over u to the 7th. And we have to be able to go back and forth because otherwise we will not be able to integrate. So then from here, I jump here. I have -1/4. Which function prime is u to -7? Which function prime is u to -7?
U to -6.
Exactly, -7 plus 1. Awesome. Divided by the same number. That's nice. You don't have to calculate anything. Whatever you get here, you put in the denominator. So do not perform any calculations first. We have to, by plugging in, we have to multiply this. -1 over 4 times 1 over -6 is 1 over 24. Then I'm done with the numbers. I plug in 2, u to 2 to -6, 2 to -6 minus u to -6, which is 1. U to 1 to -6, which is 1. 1 to every power is 1, except 1 to infinity, which we do not discuss in this class, but this is an indeterminate case. So 1 to -6 will be 1. Now you can leave it alone, or you can say, well, I don't like a negative power. So 2 to the 6th is 64, right? So 2 to the 5th is 32, 64. So 1 over 64 minus 1. It's 1 over because the power is negative. And you can change this if you'd like as 1 over 24. 1 minus 64, negative 63 over 64. That's another huge number. So what is it? 24 times 64. I got 1536. And the denominator is 63. So can I divide this by 3? Oh yeah, awesome. So 512 and 63 is 21. Can I further divide it by 3? No. That's it. So let's go back for a second to this one because it has more steps than the previous ones. I realized that these two terms are in the way. So we said, okay, let u be 2 minus x to the 4th. We have to find du, which is negative 4x cubed dx. And I could have solved for x cubed dx, which is du over negative 4 anyway. Or I'll say, fine, I'll multiply the numerator by negative 4 and I multiply the denominator by negative 4. This is 1, no change. This is du, and this is u to the 7th. Afterwards, we got